Hey folks, today I'm going to show you how I make these simple steel brackets on my plasma cutter. I use them for all kinds of things, and near the end I'll show you some variations as well. Today I'm going to model the part in Inventor, which is very similar to Fusion 360. I'll be cutting the bracket out of some 2-inch, 1/8 inch thick steel angle. So let's model that first. It'll be 1 inch wide. Okay, let's add the holes to the model. I'm going to make the holes 5/16 inch in diameter, mainly so I can use a 1/4 inch bolt. It gives me a little bit of leeway. You can use a 5/16 inch, but it'll be a little tight. To export the DXF file I'm going to need from my CAM software, I basically just select one of the faces and use the export to function in Inventor. I'm going to use SheetCam as my CAM software, so we're going to load it up. Here I right click on the parts panel and select New Part. This will allow me to import my drawing. So I'll select it here and load it up. In the drawing options, I'm going to use the lower left as my drawing position. And this way it'll match how I'm going to set it up in the CNC as well. You can also use the center, but you'll have to center your CNC to where you're going to be cutting. By default, SheetCam imports all your objects into a single layer. What I need to do is take some of these objects and put them in their own layer. We'll select the contour option marked C. We'll select the first hole object and add a layer called bracket holes. We'll select the second hole object and move it to the bracket holes layer we just created. I already have a tool generated for the Everlast using the Harbor Freight consumables, but I'm going to be using my Hypertherm with 65 amp consumables, so I need to create a new tool using settings for that. We're going to set the feed rate up there. We got to move pretty quick when we're cutting with that kind of amperage. Again, all these settings are in the Hypertherm book. I even use that as a starting point for my other plasma cutters as well. But keep in mind, these are all just starting points, and we're probably going to have to go back and tweak things, especially the kerf width. Alright, the settings are good, so what I'm going to do is let's go back and edit the name to make it a little more clear what this tool will be used for. The idea is that eventually you'll have a whole library of tools, so you don't have to create a bunch of tools. Just tweak them a little bit for different applications. If you are using an Everlast with the Harbor Freight consumables, here's the settings just for completeness. You can use these. These I found work pretty good. Okay, now all that's left is for us to actually create our cutting operation. So we right click down in Operations and select Plasma Cut. And here we have a jet cutting dialog box. We're going to be cutting on the inside of our line, so we'll select that. We'll select our layer that holds our brackets, and we need to select our tool, in this case the Hypertherm. Here are the settings I tend to start with when I'm playing with a new tool. The only thing I may change is the feed rate. Once we actually start cutting the part, we'll probably come back in here and do a little bit of tweaking. Okay, now it's time for us to go generate some G-code. To do this, I click the post-processing button up in the upper left-hand corner and basically just kind of follow the prompts through. I was already in the correct directory, but you may want to change that. Let's save this job just so we have it. And there we go. We have a job saved. We have G-code saved. I'm going to exit the thing, tell it to save the default tool set. The next step is to load it up on my plasma cutting PC. This is my work environment for my plasma cutting PC. I like having SheetCam installed with Mach 3 on the actual cutting machine because it allows me to go back and make changes very easily and quickly. It also links up with Mach 3 so you can see exactly where it is on the drawing while it is actually making the cuts. I'm going to be using this small parts fixture I designed for holding bar stock and steel angle. Here you can see me inserting the stock I'm going to be cutting into position. You can see here that I've referenced this lower left-hand corner as my 0 reference. Okay, the stock's in position. Let's go cut the part. Before starting the cut on a brand new project, I like giving it a dry run just to see how things look. And if everything's okay, I go ahead and cut the part. Okay, let's do it for real this time. I wanted to show you how SheetCam actually tracks the cut while it's taking place. It's pretty cool. Here's a close-up of me cutting the other side of the bracket. Okay, the part's cooled down, so let's take a closer look. The top's pretty good. Let's see what the backside looks like. Unfortunately, got a little bit of dross there. Most of that'll chip off, but we're going to do some cleanup. To clean the part, I'm going to use my belt grinder. It's at a fairly slow speed, probably around 1,300 feet per minute on the belt. It doesn't take much. Depending on what I'm going to use the bracket for is how well I'll give it a clean. If it's going to be welded up, I'll clean it up real good. If I'm going to powder coat it, depending on what the application is, I'll clean it up till it's smooth, wipe it down and powder coat it. Sometimes I'll just take them raw right off the plasma machine and use them for something, especially if it's going on a tractor or something. Just no need. But I'm going to clean this one up pretty good. Doesn't take very long. And that's the bracket. So what I'm going to do is I'm going to show you another bracket, slightly different here. With this bracket, it's pretty much the same design except for it's got one 5/16 inch slot that runs the length of the bracket. It makes it a little more universal. Here I'm going to powder coat these universal brackets with some flat black. Doesn't take much. Really doesn't for something this small. Throw them in the oven for 20 minutes and let them cool, and you got yourself a nice durable finish that can hold up to most of the elements. Well, that's pretty much how I make my my small brackets, and I'm pretty happy with the results. It could have been a lot better. I really believe that 65 amps is way too much for an 1/8 inch thick steel part. Probably could drop down to the 45 amp consumables would have been a lot better. Well, that's a wrap. Until next time, keep cutting.